numerically build a framework around it. A simple black and white answer exists in front of you, and you can build certain things in a cost constraint. Performance, to get performance, to hack certain performance, try to use some sort of biochemistry, right? You have to go out there, explore. You will get some of the other inspiration, and you will be able to finally say, "Hey, I am able to relate this. I will be able to build this." Let me talk to certain people. Let us all put our minds to it, and try to see if a falcon can dive, even I can make a drone that can dive. Or, just use certain things that are already available in the nature to your advantage. So that's a quick summary about what. And this is about us. We're from a company called Groundworks. We basically are an innovation company which do end-to-end product design and development in the hardware space. We do mechanical engineering, electronics, and firmware and everything. So we do complete full stack engineering. This is a website. We'll have more content available. Feel free to reach us out. We are in the space of innovating into the hardware, and yeah, thank you for paying attention to this. Thank you very much. Murli, over to you.
I think maybe we'll get some feedback from thanks for that. I think very engaging session. So right now, before moving to the next one, right? Do any one of you want to share what you are building? Maybe if you are building some hardware, maybe you want to share what you're doing and how is your journey so far and something like that. So, we could make it some more impactful before we go to the next phase. Any volunteers for sharing their
You signed an NDA.
Okay, I can talk about myself. Yeah. It's a very different something that I'm trying the first time. Alright, folks. So, a little different. So, I'm a software engineer. I used to design a lot of hardware. I used to lead software teams developing hardware. I started in embedded around 2011. I graduated in 2000. My name is Steve. I don't know if you have seen this project. There's a project called Kite Phone where I tried to get a DIY 3D printable smartphone. It was around 2017, 2018. So I used to work at InnoMinds. We are one of the few Indian companies which have a Qualcomm license. I don't work there now. I'm an independent consultant. And I designed this PCB around Tejas territory, which is 3 lakhs microcontroller. I think this is the only open source code around that. But this project is not about that. That's not a good microcontroller for any product. I knew that before I designed this thing. I needed to study the microcontroller. I was doing this as a hobby, and I was pretty sure that I did not want to. Of course, you have to get the PCB done something, right? But I was pretty sure that I did not want to. I wanted to have the entire thing done myself without spending money on assembly houses. Right? PCB, you can't do anything about it. Right? So that means I had to do soldering. That's my weak point because I wasn't doing soldering for a very long time, and I am now much older than what I look like. My hair is white, is black, so you might get confused about my age. But the fact is, I'm about 46, right? And your eyesight is no longer that sharp and all that, and your hands might have a bit of shape, right? So, and I had another friend who was doing hardware. He told me, you have to. It had like some 17 bulb headers, okay, including single bulb headers, dual bulb headers. My friend told me, you have to consolidate headers. This is not the way to make it. I said I'm a software guy. I know how to break out the interfaces. So I stuck with mine this thing. So when it came to, I assembled the board. Then I realized that there is a challenge because I can't sell the product because it's ugly. Because the headers don't align. If you see online also, you find that headers don't align in a lot of Chinese made PCBs which are very cheap. Many cases, single row headers, they don't align. They look like this, that. And I am a perfectionist, so I wanted this to reflect myself. So I went on a big detour. I said, how can I fix soldering? So what I ended up with finally is I ended up with a method where you can generate a 3D printable jig to hold all the components. Now what I am trying to do is I am trying to see how I can get assembly houses different types to actually adopt this. Can I say this as a solution for it? So I have just started on a journey where I am figuring out that there is a need because you might find it interesting because there's a lot of assembly happening, right? But there's so many both legacy products, and I visited one of those companies, and they have a board with some 200 plus components. They are all soldering it manually. And I pitched it to them. They were quite like surprised by this kind of thing. The way I have written it right now, you can actually run it on a keycard board, right? But it also means that you have entire control of the design. So I'm not just starting off this journey. We're trying to figure out if I can make this as a solution for companies. Something else like that. So the idea is that this can still be used by hobbyists and small companies and all that. But that is a very hard, from market point of view, right? Who will pay money for it? Right? It's very hard to do it. So if you really want to like commercialize it in something, you must have some relationship with assembly houses. You must give them solutions rather than because there are technological challenges, right? They'll get a thing from the company. They have to just assemble. Now I am giving them something which is productivity enhancer. So I'm trying to study that is a problem. Figuring out what is the value that they are going to see. So roughly that's what I'm doing. So the idea is like the double jig inside components, inside PCB, it aligns perfectly with it. Yeah. Right? All 17 headers, everything okay. Solder, child free. I can solder, that's all. Yeah. With great results. So that's about it. This PCB also you can check out, but I don't know. It's called Atibe. Atibe. You find it on GitHub.
Fantastic. So thanks for sharing. I think, I was just thinking when you were sharing, right, like we as a country in India, right, like we are going through this massive transformation in manufacturing, right? And so everything in supply chain, like be it raw materials, capital goods to manufacturing process, everything needs an upgrade, right? It's almost like we are stuck in 1980s. We need to move to current, century, right? Like not even decade. So in that, like I think every single small innovation like this goes a long way. Because when we go to countries like China or any other Southeast Asian countries, we see a huge difference in the manufacturing setup, right? Like, so some of these things, goes a long way in solving, but it's a given in China, right? Here it is not. So what you're doing is actually very, very interesting and it's very useful. So I think like this is what, right? Like so when software engineering meets hardware, new innovative solutions would come up. I think that's what we all need to keep looking at, right? Like hardware, yes, like there are a lot of hardware products that could be built here. But at the same time, whenever we are doing this, any such solutions that we could build would go a long way as an ecosystem. I think it's a fantastic.
Thank you. Now I have to figure out what to
Yeah.
Which is my biggest challenge.
Yeah. Anybody else wants to share? Any challenges that you are facing right now that you want some help with, or you want to build something but you're stuck somewhere, or you want to build something but the constraints are killing you, right? So we could take that as an example and maybe help do a real-time kind of decipher some of those things.
Literally, day 2 of the sprint. I still have to see more.
I hope you have more than 3 more days.
Thankfully, yes. But not many more than.
Yeah. Okay.
How do you raise funds for hardware startups?
It's a good one.
Figure it out.
Yeah. See, funds for hardware is always challenging. Right? It's not always challenging. It's not just in India, but anywhere in the globe, hardware funds are. Patient capital is not something that people are really keen to do, right? Like, so I think that's where you need to figure out like so two things, right? Like one, how do you figure out going to an MVP stage or build something or get some validation, right? Like, see, once you have some market validation, people will be ready to fund you, right? Like the biggest challenge for a lot of VCs is what we see is that they're like, okay, there are 10 other variables when compared on a software company, right? So how can you minimize some of those variables so that they feel more comfortable, right? It's almost like you will be able to raise money when you don't need money. Right? So it's like you figure out most of the things, and then they'll be behind you, right? They'll be like, okay, please take my money, right? It literally happened like for some of the companies that we work with, and to an extent, initial days of land circuits also, where like yeah. But so oftentimes you don't get money when you really need it, right? So that's where it's better to. So our philosophy, like Lion Circuit is also a fully bootstrapped company. Primer is also bootstrapped. Our philosophy is don't expect to raise money, right? Can you work around that mindset where okay, how can you build something? How can you sell as fast as possible? Right? Like with whatever you have built, find people who can buy what you have built, right? It can be very small, very crude, but I think somebody will be there to buy it, right? You need to figure out who that, early adopters.
Dress it up for.
Huh?
You gotta dress it up for. This is an innovation.
Yeah. So and then like once you do that, right? Like do more iterations, right? You get better, you sell it to better people. Now you do more iterations, sell it to a larger audience. So you will figure your way out, right? And then once you figure out like, okay, how do you build 5,000 units or 10,000 units? Maybe that time you will definitely get funding, right? Because when you have like, your target.
So we are deep tech company. We are into space hardware.
Space hardware.
Space automation.
Okay.
That is a deployment. Reduce satellite. Unfollowable antennas.
Yeah.
So we are the only company in India who is working on that, and globally there are only 4 to 5 companies.
Is there any specific like because it is your space is very different than what I was referring to? Is there any specific like IP or innovation that you?
Yes.
See, in that case, I think we can like put you in touch with some VCs who might be interested to work with business content.
For us, making an MVP like proper MVP, we can launch. We can
Yeah.
cost around 1 million or 2
Correct.
The market itself is very
Yeah.
different. So,
Yeah.
If you are going to each tech, you can also approach
multiple VCs, but this is what it is.
No, it's not just PCs, you can approach incubation centers.
Try incubation with
Incubation centers
will have grants are like that, or they might give you, they might not give you that too.
Yeah.
It's an installment based. So let's say tomorrow, in 3 days, I need to pay my heart, so my money will come after 3 months.
Correct.
So
See, like what you can do is like two things, right? Like one is your cycle times for space tech also would be longer.
yeah.
So figure out if like one of the things that we have seen that would work in a market, and we have seen some companies do that, is that people have figured out, okay, you want to enter a space market. How can you enter by not building what you want to do, but let's say some incremental stuff that you can supply to maybe ISRO, or like there are other space tech startups now. If you can supply something to them, be a vendor, right? Build some traction, build some credibility. Know that okay, you I don't know your background, but if you generally VCs are concerned about 2 things. One, okay, I'll put my money. Will this guy or team will be able to build it, right? Do they have the right capabilities? Do they have the right credibility and stuff? So once you have that, you are supplying to the space network, you're going to build that credibility. Second, you have a technology demonstrator, right? Like Purvendra was explaining some form of like POC kind of a thing. But always, if you can figure out, I know it might be hard for space, but if you can do a POC or some kind of thing where you do a technology demonstrator, that will go a long way, right? Like, but there are now few VCs in India who are ready to work with like hardware companies, right? Like so there are patient capital VCs available.
Yes.
We can like after the session I can like help you like connect with some of them.
I see all of that in like university alumni networks.
Yeah.
They are the ones who invest in deep tech.
Very good point. Investor alumni like alumni network of colleges is a very great place. Like
So got to get in touch with the innovation.
yeah. Incubation center, seniors, like
I work at research part, right? Not as research part.
Yeah.
The number of startups that came to that.
Correct, exactly. So I think see some of them are hard, right? Some of them are moonshot projects, but still get funded. But it takes more time. But if you see, it is all credibility. Companies like ePlane, right? It was almost a moonshot, but now it's getting more and more real, right? So like that, I think you can name some companies like who were going after moonshot projects, but over time they really got funded. Right?
Very good example is Rimac. Very similar to what he said, right? Like they did not directly outright say, "I'll build that, supercar." Right? They had traction from companies like from the VAG group where they tried to say like, "Hey, our battery technology, our motor technology, we'll prove it."
Yeah.
We don't need to build a full car to prove it, but we try to prove it with some other players who are already in the market. Then the traction will come. Then the proof will come. Part by part, they try to clear that. And now it's not a moonshot anymore where they say, "Hey, fastest electric supercar." Now it's real, right? It's very, very much real.
Yeah.
So, if the project is that long and that specific, if you have a specific IP, test it with somebody who is willing to use that or who gets a very unfair advantage with that IP.
Correct. Exactly.
And that gives traction. VCs will also think, hey, I'm putting this sort of money, what if it doesn't fail? I need to see what other synergies I can do. So they will try to see, okay, that IP is going to work, let it work as a part and parcel of some other synergy. It need not, okay, it doesn't work as a full single vertical on its own. They will look for that synergy. So, very well said.
So one question I have here,
Yeah.
you say you want to do tax, generate tax. Is it in terms of financial revenue which is generating the company, or it's the credibility of the company which can do the product,
Right.
do the participants over there?
Right.
What are you looking at?
See, when what you're seeing in general traction, depending on what kind of product you are building, it depends, right? And how much money you want to raise also, right? If it is a small check size, what they look is for a different thing. If you are looking for a longer, bigger check sizes, it's going to be like more revenue, more driven, and all that stuff, right? So I think it depends on what stage it is. For an angel, for an initial like seed round kind of a thing, it doesn't have to be revenue on this, right? So maybe like an MVP with some kind of a user testing, done good release. We are now working with one company who have done like beta, like they have done about 100 units. They have built like 100 POCs, the entire product, right? It's already in the hands of hands of the beta users, right? So now they are raising over $1.5 million. For that market, they are able to generate that traction. They are able to get VC inbounds, and also they are able to get like some initial sort of verbal commitments in that stage, right? So it might, still it's not done deal. Yeah, it's still not a done deal, but they have got like really good traction out of it. So which means that like they might be able to successfully raise. But yeah, so for them it's still pre-revenue, it's still like this thing, but they're trying to raise 1.5 million, and I think it's possible with their market, right? So it depends on market, and it depends on how and what the funds are needed for. I hope that.
Well, what is the name of the company?
Okay, sorry. So, anyone else? Any other thoughts?
I have a question. In finding the label and manufacturing products, they are into like home composting device. Home composter.
Composters.
Yeah, those things.
Yeah.
So like we are looking for some protocols and manufacturing partners. So how to we are running our own IT. So how to set up that legal aspects, how to stimulate that process.
Okay. Compost like mostly.
Yeah, usually you work through
plastic
aspect.
plastic aspect,
You're
right?
looking at roto molding and other this one, right? So you of course have to focus. If you're IP, you can do few layers of protection, and but that protection only lasts for certain things. So of course go through certain things in terms of NDAs and everything. Like if you visit our website, the first thing you can go do is sign an NDA, because without that, don't even disclose certain things. And if you're talking to certain things, try to get some references about it. If you go into a molder, right? If reference, like only would definitely agree. References help building trust.
Yeah.
Right? You're trusting someone with your product. Of course, they've set up a company, they've done molding. Molding is, I think, probably the easiest part. You have to trust, right? And just 2 days back, we got a client from Scotland visit here. They came to this one, and the question they kept asking is, how do we trust some other country person or somebody else with the IP? Right? So, of course, simple processes like it's okay to spend a few bucks and get it legally vetted by certain things, have a higher flat contract, go through trusted friends and references. That's one way to definitely put it, in a play, to secure it. Because without that, don't even discuss things.
Having said that, see, that's very important. Like what you said, first thing, very important. Second thing is, see, what we have seen generally as a global mindset. People are ready to work with Indians, or in India, it is, the IP theft or IP thing is, it's more of an integral thing. Like now, people, we have not seen in India, where they, if you specifically work with like some reputed manufacturers, right? Like they would not even if somebody says like I want this mold, they won't give it. India that way is more like by default, that cultural thing is there. But I think in other countries like our neighboring countries, it's not right. It's given, right? Because like you go, like you see something, you say I want 100 copies of this. They'll say, okay, take it, give me money now, right? Give me money now. I should give you right now, pack it and give me money. So it's a different mentality. It's a different mindset. So in India, if you find manufacturers in India, they are more open, right? Work with someone. See, you can have all these documents. At the end of the day, it takes time to build a trust also, right? So it's not like a one day you will go talk to someone, order a 1 million unit or something. You work with someone like order 5 units, 10 units, maybe something else. Like see how they are, right? Can they be trusted? Like it develops over time. Right? So, however, these like molding and all, like once the mold is developed. Right? What I understand is if they can have these molds, it's their property.
Correct.
Right?
You get the mold back as soon as your work is done. Like when we do molding, if we are molding a certain piece, right, we get the mold back to our office. Take the mold back when you want to inject it again, you want to run the batch again. Always take it back. Get the entire assembled unit, keep it with you. You have to take care of certain things yourself. And you can do reference checks. A lot of companies ask us for reference.
Yeah.
Like, hey, who have you worked with?
That's a good
Right? Who have you worked
reference checks
with?
is
I
very
need to know what their opinion is. They'll
Yeah.
get them, they'll call them up, and hey, can I trust them with the product? Or really, do they stick to the timelines? A lot of things get asked in these things.
Yeah, that's a very good point. Like reference checks go a long way. Like I give you example, like real examples, right? Like one person like we got like a larger order, like it was like around 4 or 5 crore kind of an order. Like you imagine, like they are coming to India, they want to like do this order. How do they do, right? It's still a quite considerable money, right? So I think what I remember is they called some of the design houses that they were working with in like a couple of years back. They had a reference check, is this like a company that
it's a legit company.
It's a legit company first of all, right? Because everything is online, right? Lion circuits, nobody who is Lion circuits, like everything is online, right? Like even now, just recently we have started these events. But until now, like we've been like very focused on online sales, right? So naturally, that question comes. They were doing a lot of prototypes. They didn't have that, somebody to talk to, right? Like we have an IVR number and stuff, but we didn't have account managers that time when they started this. It was like 3-4 years back. So for them, I think they did those reference studies, and then they did the wire magic, right? Remotely. They have not visited us. They have not visited us, right? We ship them every year, even now. So it's a relation that we have built over time, right? So now they can send bigger checks remotely without coming here and checking if they are doing or not, because they have built the trust. They have multiple transactions. They have sent the money. They have shipped the orders. They have received the products. It's in use. It's in use for 3-4 years now, right? So that kind of reliability is what you need to be.
So this is talking only about PCBs or something else?
This is the entire PCB assembled PCB. We ship it to Texas, so they use it for purpose. Yeah.
Because we have to maintain reputation, references work better, right?
Yeah.
Everybody will maintain that reputation because you don't want even one person
Correct.
speaking something.
It's the same, right?
You have to maintain a reputation.
Yeah. People also ask, like, when they're doing that, now they ask, like, can you recommend a plastic injection mold manufacturer? In India. So it becomes hard. So if we know PrimeWorks, we know few companies, we would say you can go talk to them, right? Like, we know them, right? Like, they are trusted. But if they say there is a company, can you comment anything? We cannot comment, right? Because we have not worked with them. We don't know. It's very risky because they are giving us business on your list. Yeah. So if you see now, it's a sort of a network, like a trust network.
It takes time.
Yeah, it takes time and it builds the trust network, right? So the trust network is what people will be.
Guys, so sorry to interrupt. Can we get
We'll do it.
just in the interest of time, after we're done with the session and the fireside
Yeah.
chat, we will have a networking session so we can discuss.
Yeah, we can talk more about it.
Yeah. Thank you.
I think I have only a few slides, not going to take much time. Just want to walk through a couple of slides, and then we can have a fireside chat. Okay, so I'll just walk through. Maybe I have maybe 2 case studies that I'll walk through. Some real case studies, and I think we'll start with. See, I'm a big fan of Make in India service. Right? When we launched, Make in India service is a bare PCB manufacturing service from land circuits. When we started at 14 days. We were manufacturing in 14 days. Now we have sort of come to 5 days. So we want to take it to 48 hours, right? And it's possible, right? Now we have expanded our facilities. We have a larger facility in State, where we are ramping up this production. So we are very proud, and I want to make some announcements regarding that. So we are now able to do 2 mills on the mass lab, right? So when we started, we were at 8 mills on the mass lab. It was fully open. Soldering very difficult. Assembly soldering, forget it. People were complaining, you get line circuit board, it's very good, but you can't solder. You can solder, but ICs get shorted. Right? ICs were getting shorted because we were not able to do a dam between the 2 IC pads. Right? So from there, now we have come a long way to 2 mil. I'll show I have some microscope setup. Initially, I remember when we started the company, we were scared of microscopes. We were really scared of microscope.
You can't see it in the
Because, midnight, somebody used to send an email saying, this is a microscope, this is a 100x photo. We were like, why did you do 100x photo? Okay, and then the drill is here, the pad is here, it's offset. It still works, it was quality-wise, it will still work. But sometimes, what happens, various products need various different things, and especially, our neighboring countries have overtaken us in terms of manufacturing technology. They have done a fantastic job. Whatever they are, they will copy whatever it is. Their manufacturing ecosystem is brilliant, right? We go there every quarter to keep ourselves updated.
They're good.
Yeah, and I personally travel every quarter. I make sure that once every quarter I go there now because I want to keep myself updated. How do they do it? How can we become better, right?
make that a good service.
For sure.
You can capture a lot of things and do.
Yeah. So definitely, we have now set up an office in Hong Kong, so we'll be able to take you there, or maybe do a manufacturing trip to China, right? If that is a thing we should be.
I have this from the day you started the company. You want a tour of your factory.
we can do that. Now, so we have some processes downstairs. The wet processes are in Davos Bay. It's a red plant, red category. Here, Pina, unfortunately, you see, if you observe, there is Paragon, there is Bata. Paragon is right opposite us, right? Which industry can get more red than Paragon? But unfortunately, you cannot set up a red industry in India. Only they can. They have done. So
Long time back,
now you can't set up. So we have to set up a new plant in Davos. It's a much larger facility there. So it's about 15,000 square feet of factory floor area. Fully automated machines. We'll be able to have a separate one-on-one. So in that, now we have 2 mills autonomous dam. The second is high definition legends. So legend was another thing. People were I remember 2017, 2018, right? Around 1 or 2 years, around the time we started land circuits. It was very painful, right? I have to remember that before we show what we have done, right? You have resistor, right? On the resistor, legend used to come. Legend used to get printed on the solder pad because the accuracy, our printing accuracy was very bad. Offset was very bad, right? So we didn't stop there, right? I really, from bottom of my heart, I want to thank every single customers who have given 1 star on Google, given 5 star on Google. Everyone, we thank them because they are giving us something, and that is helping us do better, right? So what we have done now is we can print your photo, we can print animes. What is the character?
Dragon Ball.
Dragon Ball, yeah. So we print all. We can print anything. You can print your photos. And we have achieved 20 micron. 20 micron accuracy. 20 micron is the printing accuracy on our shop floor. All Make in India service and custom service go through this. 20 micron printing accuracy. So this applies for both solder mask, this applies for solder mask, this applies for legend, and this also applies for copper pattern printing. So all copper patterns are 20 micron accurate, which means that if you have a drill and if you have a pad, the offset would be within 20 microns, right? So initially we were way off. Now we have brought it to 20 microns. So our process control is about 20 microns now, which is about 0.75 mils, 0.75 mils. Right? I'll just I've set up something here. So we have a circuit board which I just took it from Make in India service today, and so this is what I'm talking about. This is a LGA package. You see there is a solder mask dam in between, right? And then you can see this is printed exactly where it is supposed to be. So this, like when you see in naked eye, you can't even see this package. This is almost like 100x zoom. So you can't even see the package. It's a very tiny IC. So and then like you see the print, right? The print accuracy is extremely, within the 20 micron 10, right? So print accuracy and the solder mask stamp is achieved. Copper printing accuracy is achieved, right? But what do you see in this? Like, do you see something not very good? The jack thing was that particular customer design. I looked at a few other boards, it was fine. Not the jack. But what else do you see? Like, are you happy with everything here?
The tracks also, yeah,
I think this particular design, that's why I have few more boards. This designer, he has done something, but other boards didn't have. So it was not like process thing.
What is social thing that?
Hot air solving, right?
Okay.
So if you see here, like these are LGA packages. You can't even see in the eye, right? So this, right? All these, right? So you have, this is a HSL process, right? HSL process is a very common process. Everyone does it, right? So we were not very happy about HSL process, to be honest. Like, we tried in multiple machines, we did like so much research. We are not happy with HSL. So we have a R&D lab. We came up with our own process now, right? So this, to the point, like we would not have been able to do this day one. Maybe 8 years down the line, we can afford to do R&D. And then we have an R&D. I'll show you a new process. We have not even named the process. It's a new process that we have come up with for surface finish of PCBs, right? That we do on knee panels. We are going to be rolling out on knee panels first. I think from April. And that process, basically, what we have focused on is, one of the major thing was like, if you see like this is not fully level, this has slightly bulge, right? So when you have like a ball grid array or this thing, when you are doing soldering at home, it will become very difficult. You can still do it in our assembly line. You can still do it in our assembly, but we have trained operators, we have like some machines, reflow, and But when you are doing it at home, you will not be able to do it thoroughly. A good soldering person will be able to do. But the idea is we want to empower everyone so that you can do prototypes in home. You don't want to come to us for and pay us more for assemblers.
For small volumes, it's more painful.
We do that. But what happens is a lot of people they want to do something, they've got the boards. The enthusiasm is there, like you want to like just quickly solder, test it, go to the next version as soon as possible, right? Like because hardware is always iterations. So for that, what we have done, we have come with a new process. So I'll probably this area. I think the board is not clean, but you can see you can see the difference on the pads. It's more flat and it's more even, and you have a more greeny kind of a structure. It has a more matte finish. Matte finish always is better. So in India we are so much tuned to glossy, right? We want everything glossy. But actually for PCB, matte finish is the best because you have more wettability, solderability. Solderability is very good, right? Like even solder mask, we are considering to switch to matte finish with a darker shade, so that it's a hard sell. Like it's more expensive. We are ready to do it, but we did an experiment and some of the customers didn't like it. They're like, why is the board dull? Board is not dull. It's a matte finish.
Life of the board is very good actually.
Life of the board is very good. Solderability is good. Wettability is good. Right? So we are trying to now come up with some kind of a solder mask which people will like hopefully, and also gives a matte finish. So you see, like running a manufacturing is not only about technical. Sometimes it's all about like what does your customer expect? Sometimes we have given very good quality boards, like people don't like it. This board is one example. Like if you see the board in naked eye, this has this solid mask is a very excellent addition. Solid mask. It's unfortunately we have to import from UK. One day we'll do it in India. But here with this solid mask, this basically we use something called a pre-clean process. We have a chemical cleaning process. Like after all the copper printing is done, we do a chemical surface clean, and then solder mask is applied, so that the solder mask sticks to the copper in a very nice way. With more, it doesn't peel off and all this stuff. So with that, what happens is when you see, it looks the copper tracks are brown. Copper is brown, right? Like when you do this cleaning process, the copper color becomes more bright copper color. And then when you apply solder mask, after solder mask is applied, when you see, wherever you have that copper track, it looks brown. So when you see good quality boards being manufactured in motherboards and everywhere it is like that. But what we see is when we send to people some people in India who have not seen such boards, they think that this is a bad quality board. Why is it copper? Until now it was dark green, now it's brown. So you have done something wrong, right? So a lot of times, the reason I'm saying this is, so when we are doing any experiment or anything, we would never give you like bad quality. We always want to make it better. So like would say if if you have any concerns, like ask us and we'll help you understand. But also like these are some of the learnings that we had. I'm just sharing the learnings. And so this is the new process that we are going to be doing. We are going to be rolling out this process from April in all Making India and custom services. This I don't know what to name. This process will name something.
I have fancy name. So that customers should want that.
Yeah, exactly.
It's Mac, right? So Mac got up.
Yeah, Mac got up.
Mac with a key.
Yeah. So something like that. So I think that's all. Anything else? I'm not sure. I think that's pretty much it on the fabrication. So let's move on to case studies.
So like one curious question.
Yeah.
So you have talked about R&D and all that, right? So basically, it's like you have to experiment to get the process absolutely right. That tuning is basically owned by the house.
So what we do when I say R&D, last time in the last meeting we announced one new service that we innovated in the lab. This month we are announcing this. So last month we announced something called a direct gold immersion. So depositing gold directly on copper is a very hard thing, and we are able to achieve that. We are able to achieve about 4 microns of gold deposition on copper. So this process is specifically used for a lot of RF applications where you don't want any barrier between copper and gold. So you want direct gold deposited on copper. So generally ENIG is very common. So you have a nickel barrier. So the board that you showed is also ENIG. So you will have a nickel barrier. So because gold is very expensive, right? So you have copper. You build nickel to about like 1.2 microns, and then you put gold on top of it. But gold you deposit only 0.2 or 0.5 microns, right? So that's an ENIG process. So now when you have high-speed RF applications like antennas and 5G applications, you will not be able to use this nickel barrier. So you want to put gold directly on this. So until now, what most of the there are only 1 or 2 factories in India who can do this process, and they all import this chemical from Japan. The company in Japan who does this, and nobody else does this. So we came up with our own chemistry, right? Like where we have figured out how to deposit this thing, and we have done that. We have done few batches, and then we are rolling out this for some defense applications, right? Like we are giving you some defense applications for radar applications. Very good, yeah. So that was last month. This month we are rolling out this. So our goal is hopefully every month something or the other we will do. It's not easy. So this has been, it's not a 1 month effort. It's been going on from quite some time. Now we are able to come get this out of pipeline. So eventually our goal is have all the solvent mask, everything done in India, right? Like right now you have to import everything. All the raw materials, to be honest, like we are importing, right? We are doing all the process in India. Our value add is basically processing the PC, right? If we had raw material suppliers who are Indian manufacturers, we would be the first one to buy from them. Like we have been talking to a lot of people to replace some of the things after we get to know there is someone. But it is hard. Like there is no good ink manufacturer, solder mask ink manufacturer in India. Can you believe it? Like we do a lot of PCs. Yeah, our PCB market is so big. We still import a lot of solder mask. We import Legend, the text ink, right? So printing industry is so big, but the printing of the PCB ink is not.
Everything comes from Japan.
Everything comes from unfortunately. But that's why like so many education institutes having chemistry, we should think very hard. Why are we not able to produce these things from India? And the funny part is, like when we talk to like some of these companies in Germany or Belgium, and we see who are working there. It's basically a very sad state.
We are also a chemical powerhouse. Yeah.
We're a chemical powerhouse.
Like for agriculture.
Yeah. So exactly. So I think that is where we have missed out a couple of decades for electronics, right? So the reason I'm saying all these things is we need to know the ground reality. All of us need to know the ground reality so that we can then see what we can do. Every one of us, like what we can do in this, right? So the ground reality today is we don't have any of these things right now. So now we spoke about 20 micron accuracy, right, in PC. Now when you go to semiconductor manufacturing, it'll be 10,000 times, harder than this, right? It's almost similar process. You basically print, but it's a very different process. We do a lot of sputtering and stuff like that. But it is 10,000 times more difficult than to do it. And all the machineries, chemicals, everything has to come from other countries. Right? So with that, let's move on to the case study. So okay, so unfortunately for this case study, I cannot disclose the name of the product, but I'll go from, it's an IoT product. Basically, it had some data collection and it had a LoRa-based connection, and this company had to scale from 0 to 5,000 units in 6 weeks, right? In 6 weeks. And how this was done, right? Like, so basically, I think a lot of things on theory side, like, and also practical, like, Bhuvendra spoke about. Like, that's very, very important. Like, he mentioned about 2 weeks for this thing. From a lot of product standpoint, 2 weeks is also a luxury. You can actually spend 2 weeks, right? Sometimes, not always, like 2 weeks is a good amount of time because when you have a serious like product design, industrial product design you have to do, you have to give 2 weeks. But sometimes you don't think about another constraint, right? Like market dynamics. So this customer, this product had to be released in a particular season. Christmas or like some summer, winter kind of thing, right? So it had to be released in that season, and he had to capture that market, or he had to enter that market, get into that market in that time frame. So he had only 6 weeks, but he had he had done a lot of MVP. He had done a few boards with us. We didn't know like he was building this. He had done a lot of boards, but it was very basic. Like it was nowhere ready to production. So he came to us and said like, we have done like few hundred boards. Like, how can we take this from here to 5,000? And then we were happy, like, sure, we'll help you out, like, we have a facility and all this stuff. Then he told in 6 weeks. So, and then we were like, okay, This is interesting. Like, can we really do this? And what are the constraints? Right? I think here, then we saw, and we specifically I've written as 0 because whatever he has done, right? Like there's MVP done, everything is done, but none of that is production, right? So it is almost 0. Like we have to start from 0th unit, go to like ramp up to 500 units in 6 weeks. So what we did, like we understood the constraints. So he wanted to not go to China, right? Like Indian company. It's an Indian company. They didn't want to go to China. They wanted to do it in India, but they wanted China prices. Like they wanted to make sure that like, the prices are this time. And we are okay. We are happy. Like we are very proud that in a lot of ways that we are able to actually meet the production volume prices to China. Like a lot of people didn't believe it, like he also didn't believe it. We have executed such projects, like this is one of the examples. It is possible. It is possible by a couple of 2 or 3 constraints again, right? One, design. You need to really optimize the model. You need to go to a level of each resistor and capacitor. Make sure that it is not more than like 10 paise, whatever, 20 paise, whatever it is. If it is 60 paise and you are doing 5,000, like that adds up, right? So you like 5,000, like eventually, like hopefully, like a month, right? Like now, so that would put to like 50,000, 60,000, 60,000 a year, right? Like you need to be very cost conscious, right? So what we did was basically, so cost was a big constraint. Second, we have to build a production ready device, right? So, and then the third was basically, he wanted to build the entire thing, the entire like box build, everything, enclosure, everything here. But I think we said like first batch will not be able to help like all the with the enclosure manufacturing ourselves. But we were ready to work with the supplier that he already has. So we bought the enclosures with the supplier that he already has. All the supply chain we started figuring out, like our supply chain team figured out like where to buy what component, like in the supply chain. But I think the first week we did like 2 or 3 prototypes. 2 or 3 prototypes in the first week, right? Like, so why I'm saying this is because you need to give time for iterations. So when you want to take a design to production, it's not going to happen in the first product. At least like in whatever amount of time that I've spent in electronics, like maybe around like 15, 20 years now, like I've not seen one product which has gone to production in the first design. Like design iterations are given, at least 1 iteration, right? Like even if you are the best of the best, you will have 1 iteration. So plan for at least 2 or 3 iterations. This is minimal. So, and now how do we do this faster, right? So we had like a service where we do like a flash, like 24 hours time. So we did like 1 build, saw like how the constraint, like what the design needs are. We did another design, like in about a week's time we are able to get to a state where it's production ready, right? We are confident that we can build this and also still plan a lot of components in a way that, okay, you take this footprint, but you also put another footprint which will match. If you don't get this component, you get this component because you're in a rush. You cannot negotiate if you're in a rush, right? Like you cannot get your prices if you want super fast and you want it at a price that you want. So we had to plan like multiple points. So that is a very common thing. So whenever you are doing a piece of design, have maybe 1 or 2 footprints from super critical, expensive ICs, modules, right? Like any microcontroller, right? Like have a backup. It's difficult, but you should try. Modules, have a backup, right? Like especially wireless modules. There are a lot of wireless module manufacturers coming from India, but the ecosystem is still not there. So we'll have to import the wireless modules. So plan for backup, right? Suddenly they'll say, I need 3 weeks to manufacture. You cannot do a 6 week, production in that time frame, right? So plan for backup, right? Footprint backup, right? So these are some of the constraints that I can think of. So once all these things were done, we were able to place all the, set up all the supply chain, get all the components, start the fabrication in parallel. So fabrication, at least like for such volumes and all, we need like at least 2 weeks, 2 to 3 weeks. We ideally take 6 weeks, but this was a super fast like thing to be done. I think we did it in 2.5 weeks, I think. And then we took another like 1.5 weeks for the entire assembly, and then like what's built, testing, and all that stuff. So typically, a typical production for if you want to do a 5,000 batch, you need to keep about 8 weeks, right? Like 8 to 9 weeks. Once the design is finalized, do this thing. But on a rush basis, like 4 to 6 weeks is possible, but don't go always to rush, right? Like so, one thing that we have noticed is that always like customers like come back and say we are in a rush, we need to get this thing. So it's a when you are doing prototypes, it's a good thing, right? Like you do in a rush, you need to really iterate faster, right? So like for example, you were asking about funding and stuff like that. The best thing in software is like you can do a compile, run, sleep, maybe not even sleep, you get the results, right? But here the compile, run, execute cycle is longer, and it costs money, right? One mistake, it's like again you need to. But I think if you plan, you have your mindset for 3, you'll be able to get to a production. All right, okay? You'll be able to get to a production ready. Keep 3 at least, and keep your always keep a think about like what other like if you are putting a resistor or component, like you need to really think whether it's really necessary for me, right? Is this really necessary? Can I live without it, right? If not, you put it. If you can live without it, if the design works and it's stable, don't have any constraints, it's remote. See, a lot of times, coming from semiconductor background, so my background was in semiconductor, I used to work for Texas Instruments before. I've done like application notes, and if you go to like sensors and read any application note, you might find my name there. So we used to put all kind of resistors there. We are selling ICs. We are selling ICs, right? We don't care about resistors. So we would give you more like more.
There should be options should be there so that
Yeah.
customers can exercise various possibilities.
Yeah. So the application notes and reference designs will always have more resistors, more capacitor, more ICs. So for example, like now that I'm not there, I can talk about it. So we used to cross sell a lot of ICs, right? One of the strategy was like you are selling a sensor front end. Can I sell a DAC along with it? Can I sell a microcontroller along with it? Now what I would do is I would put all these things together and give you a reference node. So now if you just do whatever it is saying there, you get a perfectly done product, because we used to do temperature testing, reliability testing. We used to sometimes for reference designs we used to go to MTBF analysis now for some of them. Yes. Yeah. So these reference designs from here very sturdy. Right, very good, but comes at a cost. Yeah. So
almost all
companies follow the same thing. So
if you don't do it with TI, you definitely don't do it with ADI.
It's more expensive. So be very conscious, right? Like if you take a reference designs as your start point to a design, be very careful about what is coming along with that, right? The advantage is you will have like bill of material, you will have a lot of things already pre-done, but just be aware it's not a production ready design, right? It's a reference design. You need to use it as a reference. For production ready design, you need to really think hard on all sort of the blocks that you are working with. And as you said, like already in the market, like you will know certain semiconductor companies more expensive than certain semiconductor company on certain components. But still, do the analysis, because there are certain product lines in more expensive, traditionally more expensive semiconductor company, that some of the product lines actually are cost lower than TI, for example, right? Why? Because it's about process nodes, right? They have a better process node for a particular process than TI, right? Like it's most likely not because TI has covered everything, but still, like go and look at it because there are few things which would be cheaper in some other semiconductor than this.
If you look at just the IC part, it might be expensive.
Yeah.
Overall
solution.
it will be less.
Exactly, exactly. So that's where, like, do the analysis for the overall solution. That's a very important point because sometimes we have seen, let's say you select an IC, that IC particularly need a very high accurate resistor, right? Like let's say you want a 0.1% resistor, you're done, right? Whereas like if you can find another competitor who doesn't need a 0.1% resistor to maintain similar whatever tolerances, you're great. Your entire solution cost will come down.
Yeah, even though the chip itself costs a little bit more.
Yeah.
But the entire, like, if you add the resistor,
Yeah.
the availability.
Exactly. Yeah. That is one. The second is sometimes you will have to also look out for, you have particular IC, but you need a specific regulator which is not there inside. So for example, let's say there is IC A which can take 12 volt and do everything internally. But if you have solution B where you need a 12 volt rail, you need a 5 volt rail, and you need a 3.3 volt rail. And if you don't need these three rails on your design, you will be spending extra on the regulator solution. It's not just the regulator IC.
PCB space.
PCB space,
Yeah.
easily one inductor, one capacitor,
Right, cover and display.
bunch of resistors.
And then there are problems with resistor values as well.
Yeah,
Matching.
yeah, matching, and especially when you get into DC-DC buck boost converters, you need to be really careful about loop stability. So you get into all those complications if you don't select the right IC. So spend more time. So in schematic design, right? So when I see like people say I do schematic design, I can design a schematic. It's not about doing schematic design in KiCad or Eagle. It's only schematic entry. What you do in KiCad, any other tool, Altium or anything, it's only schematic entry. The design you will be doing mostly on a paper and stuff like that, like figuring out what to do, right? So spend more time in component selection and identifying the right component. So once you do that stage properly, then you are like set. You will be like, your design will be stronger, the downflow from there in all the other design stages will be smooth, right? The other stage that you need to really be careful about is placement, right? Component placement. The placement design on your board needs to be very well thought so that sometimes you can reduce your space, which means cost of the PCB and so many things. So you will be able to reduce. So these are some of the design inputs that you can consider while designing and executing. Right? Then, so this was one case study where we did this 5,000 units thing, and the customer was also surprised we were able to match the Chinese prices. So then case study 2 is Glyph development course. Right, Srinivas is not there today. He's traveling back from the Hong Kong staying office. But typically, if you go and search for Glyph C3 or Glyph, this is a ESP32 development board. There's nothing fancy about the board itself. But what is really fancy about it is he was able to do this entire thing, and he's able to sell this at 434 rupees. Right? And it's completely made in India. Right? So why buy Arduino when you have this? Right? Like, why buy more expensive stuff when you have affordable stuff which is completely made in India? Right? So check out Glyph, PCB Cupid. Like, his company name is PCB Cupid. So when he came, he's like, I want to like launch a, development board in India, which is very affordable. I said like, what's the price range you're talking about? It's like 300, 400 rupees. And then we started laughing like initially, is it really possible and stuff like that. And then I remember, then we sat like, we said like, I'll put some thoughts around it. Give you some more realistic, whatever, schematics and stuff. Like, let's see if you can optimize the bomb. Right? I think when he came up with his initial bomb, the costing was around 600. The manufacturing cost was around 600, 700 rupees. Right? Which was in line because like Adafruit and all sell a similar board for 1,200, 1,800 rupees. We thought like, okay, this is good, like 600, you have done a fantastic job. But what he wanted to do initially was, the constraint for him was 400 rupees, right?
The Chinese place.
The Chinese prices, right? So it was like $5 kind of a thing. He wanted like a $5 development board in India, if it is possible. So then we sat down, we did like, okay, what are the features that you want to do, right? So he stripped down a lot of things. He took like some of the things like, okay, these are the things that Adafruit uses, these are the things that smartphone uses. We want to be compatible with most of the development, Docker cards and stuff like that. Can we build something using those parameters at a price that should be no-brainer, right? And with that mindset, with those constraints, we started working out, and finally, he's doing like thousands of boards every month now. We wish like he would do 10,000 or more boards every month, because I'm sure like Arduino is doing more than 1 lakh board every month. So we are nowhere close, but this shows a path, right? That it's actually possible to do that. So when I ask Srinivas, like, what's the topmost question that you get? He's like, is it really very good?
Everyone asked that.
The first question that he got, like when he launched, was, dude, like, is it really made in India, or are you just putting the lion logo and doing it? So we have told him to do wherever his boards are running in the factory, we have like told him like, to do like a video of actually being done in India in the factories, like, and put it out there, because it's actually possible. It's like, see, for him, I will not take much time in this case study, because I think we're running out of time, right? Like, what's the time? Time check. It's already 9:40. Okay. So just I'll quickly wrap it up. So for him, the time constraint was, for him the constraint was the cost, right? So to meet the cost, he really optimized the board so much. Like, it looks really cute. Like, can you get like can you get one C3 development board? I want to show you. Yeah. So it's really optimized. The space, the board size of the size of the board was so optimized. The cost of the PCB came down significantly, right? And he optimized the BOM so much that only things that are really needed is kept. Everything else is BNP, bottom the cost of components, right? And because he had also volumes, we were able to get like negotiate a better price, and also we use all these ESP32 very commonly in multiple production. We were able to get a very good price for the production, right? So overall, the cost of the product is way less than 400 rupees, but he's able to sell it for. So the product cost is actually way less. Right?
What's the name of the company?
It's called PCB Cupid. PCB Cupid, and the board name is Cliff Series.
I actually heard about it today.
Oh, is it?
Yes. I told somebody else I'm going there, and then he's saying that, I don't know where he made this thing. He said, I'm going to use this board for my next thing. He's currently using the Shio.
Okay.
That thing, right?
Yeah.
He's saying next version of the product he wants to use.
Yeah.
And I'm like, how come I haven't heard about it?
Correct. Yeah. So this, we like, as long just like everything else, like he's also bootstrapped, right? So we encourage bootstrapping more and more.
Let's give him some visibility.
Yeah. So please help him out, like for his product, like share to as many people. Like this product is very stable, by the way. Like very reputed companies, I think we can name the company also Titan. So including Titan is using in a lot of their products, right? Like it's going places. It's like B2B is one angle that he's looking at. B2C is the further forward is thing. So it's very stable. He has engineered it like, so though it's a development board, he has done a really good job. I would say this is a board, right? Like this is a small tiny board, and everything is done in India. Like fabrication is done in our facility in Downstate, assembly is done in our facility in Electronic City. The final assembly is done here, and then we do the entire packaging and everything. And the box, like we even put it in the box and ship it to customer. Because
You do that part also?
Yeah, because see, we do drop shipping. Because for him, the shipping cost also is important, right? Like if he's charging 434, he cannot charge 200 rupees for shipping. But we have some shipping arrangements with DTDC and Blue Dart, which is works out to be much cheaper for him. So we are helping him with shipment also. So he will give us like, we have an arrangement where like, he will send us like a list of customers that he has to send to every day, and then that it goes to our operations and the back end just goes to this. So it's shipped from our facility. So we would encourage like anybody who is building anything, right?
Is he only selling on his own website, or
Yeah.
is he also selling inside?
He's selling on his own website and he's selling on Lion Circuits also. We have a e-commerce platform now on Lion Circuit. If you go to Lion Circuits /parts, you can order components. We are setting up a warehouse in India for all electronic components. We are stocking his board in our inventory and shipping. So he places the order. Either he gets through this or we get through our e-commerce portal. We ship it from our facility. So we have a lioncircuits.com/parts. Is the e-commerce thing. We have almost like we have a lot of parts. We are going to be stocking a lot of parts in India. We will be doing like super fast shipments on components because my personal goal is to build a 48 hours PCB two layer 48 hours. But what is the use if components take like
1 week, right?
So I had to change my personal aim to also include components. So now
Blinkit and Zelda.
LinkedIn for components. That is always true, right? First order components, then order PCB.
Yeah. So we want to change that, like, because what happens like when you're doing design, you think about some other IC you want to order, and all you know it's in US warehouse. It takes time. You have customs. You have so many hurdles. But we already, you can order components, even 400 rupees component on our platform. On the e-commerce portal, you don't charge any customs, you don't charge anything, just gets delivered to you. It right now takes 7 to 10 days. But we mentioned there, if it is mentioned as 7 to 10 days, it takes 7 to 10 days. If it is mentioned as ships in 1 day, which means that those components are in our stock, in Bangalore. So it gets shipped faster, it ships in 1 day. So eventually, like we want to stock more and more components in Bangalore so that it gets delivered to you in 1 day. So that's all from my side. Like, last thing, if you have any, not just like the development boards, if you have any products that you want to build, I'll pass this around. Like, pass it around. So any products that you want to build, talk to us. We have today we have Rohit, we have Kushal. They're all account managers. Rohit is basically heads the sales. So he's there, and we have also Kubendra, Sanjay, Kushi. From Brandworks, we would encourage like chat with them, like talk to us. I'll also be here. Like I know if you want to share anything, I'll be happy to listen. And so we'll be happy to work with you in any way we can, and we want to help any hardware company in India, right? And do reach out to us. Yeah. Cool. So.
Thank you. That was a very exciting session. Thank you. So guys, right now it's about 7:45. We run a little bit over time. We have planned a fireside sessions where we have a few questions for. So we have Kunal here who had prepared a few questions for Murli and Purvendra. And we also wanted you guys to be able to ask questions to Purvendra and Murli. So if everybody is good on time, we can continue with that session. Otherwise, we will end the session here and move into it. So just with a quick show of hands, with a quick show of hands, how many people are okay to move into 5? So that's about 15-20 minutes, and then networking. So how many people are okay with that? Okay, it looks like majority of the people are okay. So we will move into fireside chat right now, and then after that we'll break for some snacks.
Maybe what we can do for people who don't want to continue,
Yeah.
let them have snacks and maybe because.
I think that they will
Yeah.
also stay for networking session though, right?
No, or maybe.
Yeah.
Challenge is the distance.
Correct. So what we can do, maybe you are saying like quickly get snack.
Now we get snacks, we can have a longer session and then we'll be able to. Yeah. So after that we can just.
Is that okay, guys? Like, I know
I
you
think
guys are
it
from.
will get dragged.
Get dragged. Okay, whatever you.
Yeah. We'll set up snacks here and
Okay.
then we will continue
Done.
with the fire.
Sounds good.
Yeah.
Let's do it quickly, huh? Okay, we'll do a standing 5 seconds.
I'll just, yeah.
Or maybe we have the
Push in, no stand,
Okay, guys, we'll promise to make it quick.
So I think everybody can hear me properly. So yeah. So this, as she told you, is a part of the pattern question. Now you can also, when there will be answering the question, you can also your question rather than through that answer, you can ask that as well. But we will have a dedicated round for the audience. So we already have a question. So starting with the first question. And we will be asking these questions, both of them please answer. Okay. So how do you ensure that your team's creativity doesn't get blocked by the constraints?
So essentially, team has to be creative to do a lot of innovative ideas. Right? If you tell do it in this time, do it in this one. So usually you kind of block some sort of creativity. So what we stick to is we stick to our frameworks. Right? When we stick to a certain framework, they are allowed to explore, and it's okay to let's say fail at certain ideas because when you have certain frameworks in mind, you're not worried whether it will work or not. You trust the process, you trust the framework, then the fear of failing goes off. Then the creativity unlocks immediately. So that's what we do. Yeah, you want answer.
Creativity and creativity. So I think see a lot of times innovation is like if you do innovation, right? If you do R&D, it cannot be time bound, right? Like you have to think that. But when it comes to production, it's all about execution. So you need to know the difference. Like so, for example, it is also a lot of things to do with the org structure sometimes. Like depending on how big the team is. You cannot have R&D manager, R&D reporting to like operations. Like you cannot have an R&D head reporting to COO, for example, because you are fighting with quality, time, and innovation, right? Like so, certain execution stuff has to be in that board. Certain things has to be given that space. It needs to be isolated. I believe, like depending on the case, it needs to be thought through and given that constraint, and the people needs to know, like, hey, am I in a R&D kind of a thing? What is my role? What are my constraints for some of these things? So when it comes to production, definitely execution takes highest priority. When it comes to R&D, there's no time constraint. Like even if time is a constraint, you cannot. So you'll have to balance it out. It's always a hard thing.
So moving on to the next question. This one has a little bit of sections here also. So have you ever had to scrap any idea due to constraints first? How do you pivot and what were your learnings from that experience?
So yeah, we had to scrap a lot of ideas initially, like a lot of innovative things were there. Like we wanted to do so many things in electronics manufacturing. We wanted to set up a huge factory in 2017, PCB factory. we wanted to set up like India's largest PCB factory. We didn't have any, right? Like, we come from a, very humble, background, and we don't have any, silver spoon backing to, so we had to scrap that idea, right? Like, we wanted to build, like a lot of these raw material things. Like even now, we want to build proper clad laminate factory in India. It's not possible. Like I don't have enough money to build it. But the idea is there. We have a vision to do it. One day we're going to do it, but right now it's done. So the way we pivoted is like we slowly built from 2017. So I moved back to the US in late 2016. Slowly built from zero, right? So right now we have a few factories where we are doing. We want to build more, right? And the only idea is how do we take the ecosystem to the next scale.
A lot of times, I think when we were doing a prototype with one client to build a tea making machine, a tea dispensing machine. Initially, we built everything. We built heaters, we built everything. We made kind of almost built the MVP as well. And the customer even said, "Hey, look, I want to put it up in a place where there's no water. I want to make a machine which I don't need to wash." So that sort of a constraint came in, and we had to scrap the entire idea, go through. Like, how do you not wash it? It's going to contain bacteria. It's going to, if you don't wash, things are going to go bad. So, yeah, we had to scrap that idea, re-innovate everything, figure out how to make things into that things don't stay, even if it's make it disposable, changeable. Had to completely pivot. So, yeah, it's definitely had to do that, and it's worth it. Worth it.
So one thing, since we are also connected on the for them. So innovation happens after failure. So when we do get those failures, that is where we pivot. And it's something that we are doing all this with those time constraints. So that is also very good. Yeah. Moving on to the next question. Given today's global supply chain issues, how do you design products that are resilient to material shortages and global geopolitical issues?
Certainly, as I experienced in this clearly.
It's very hard. It's very hard because I think government also understands it, right? To a large extent, we cannot. Right now, we cannot live without our neighbors.
Especially by importing countries.
Because importing raw materials we can't, like right now. But what we can do is we have to work in every single aspect, right? Like as sir is working on this thing, everything in and around the supply chain, we have to work in India, we have to work hard. Right now, for supply chain mitigations, what we do is we work with multiple certifications. Like we have some suppliers for components from Singapore, we have from China, Taiwan. So it's one level of de-risking. And definitely we also have supply chains from Germany and US. It's a couple of layers of de-risking. But right now the way the things are going on, it's very hard to say what's going to happen. But we better get real and execute on some of the projects that government is taking. Like government's vision to do it in India needs to be done faster. Like semiconductor, mission, or anything of these things is not going to be easy. It's not an easy thing. Like PCB factory, setting up PCB factory. If somebody wants to set up a new PCB factory, it's going to take time. For the new one, if they don't know anything, they have new money, it's going to take at least 3-4 years. Minimum to run it properly. So for semiconductor, that's one of the important aspects.
But we are getting our first chip this year, right?
Yeah. So that is possible mainly because for example, Micron and these companies, right? They already have the technology. It's only a place for them, right? That also is not easy. So you're setting up, even if you know everything, setting up in India with all the chaos that is there, it is not an easy thing. Especially that is also under red industry. Semiconductor is also red industry, so it's not easy to navigate this. It's a lot of red tape, but hopefully because in Gujarat, it's in Gujarat. Gujarat, I have personally seen things are way better. Way better than Karnataka or Tamil Nadu or any other southern states. Way better. Processes are way better. Hopefully, we get better.
One question. What about the manpower semiconductor industry? We don't have an industry here as of now. How do they manage manpower? That's my question.
So, lot of semiconductor manufacturing in Malaysia, Philippines, Singapore. Most of the factories there are filled with Indians. Filled with Indians. Like you go to any factory, you see Indians. So we'll have to bring some of them back, maybe, right? Like them training other people in India. So what happens is like, so there is a good amount of knowledge in working in semiconductor industry by all the people. So it's now about how do you incentivize them to come back.
That's what Taiwan did. Right?
Yeah.
Taiwan and China, they brought back people from the US.
Yeah. So China is very clear. Like China, not just labor, they bring back. They basically, if you are an expert, let's say you're in the US, you are an expert in laser. They'll fund you. They'll say there's no other option there. That's it. You have to go back. But the good thing is they'll give you like funds. They'll pretty much give you one district sort of thing. You are in the center of the district. You build the district to be a laser hub, right? So there are a lot of places in China like that. If you go to some area, that area is only specifically good for a certain thing, right? It's just amazing. Like one region is fully laser. They make laser diodes, they make laser everything, laser machines. So how, when we dig more and understand how they do it, it's because of one guy who came back from the US. He set up the laser technology. So he gives, and he brought all his students, his industry people back into this thing because he has funds. And then they have set up everything around. They have laser fabs, they have laser diode manufacturing units, they have equipment manufacturing, everything. Optics plays a huge role, right? Optics, you tell one company in India who can do good optics. Don't we have good physics people? Don't we have so it's about mindset, right? It's about specifically having industrial mindset. See, we as a country became very well about software and everything. Services in 2000, products in 2011 decade. This decade we need to get better in manufacturing. So there is nothing, we have evolved fairly good in the last decade, at least from 2011, like this decade, like whatever, we have fairly, we have progressed a lot as a nation. This decade is all about manufacturing and products. We need to get better. Get better in all areas, not just one. We need to get better in optics, we need to get better in laser, we need to get better in semiconductors, so many other areas.
Basically, engineering, all aspects of engineering.
All aspects of engineering.
So we don't have
We need to develop that industrial mindset. We lack industrial mindset. Everyone wants to do engineering, everyone wants to sit in an AC office, work in front of a computer. Nobody wants to come to the shop floor and build something. Because when you do R&D, you cannot only sit in some place. You have to be also practical, right? So that's where we draw a lot of inspiration from, like Sir is doing from software, he's doing hardware, and then he's building. It inspires us, right? Because that is how we have to build as a,
There are no more silos.
There are no more silos. See, that's why we are very open. So line circuits, anybody wants to come, discuss, by the way, Srinivas and all these guys, I didn't know him, right? He came, he said he wanted to build, we supported, he built, right? We have Prithvi here today as an audience, but he has built a lot of products. When he came, he built, we are open, we want to share whatever we can, and we want to do it more.
Yeah. Second only, I think Chatpat and all toys focused industry, like you said, cities focused on certain things.
Yeah.
We had it in us. I think it's just going away. We need to kind of do real homecoming, and we need to rely on more local empowerment.
Yeah.
I think COVID taught us a big lesson. We had nowhere to go when injection molding had to be done, facing had to be done, anything had to be done. Forget about different city, forget about same city. can't move more than 3 kilometers, 2 kilometers to get the things done in COVID. And the amount of runaround things to do, get permission from police, that taught us to, be resilient amongst such changes. And of course, anti-dumping duty and everything is kind of gone haywire right now. And focusing on building things in-house, having things for ourselves as a backup, which is the best way to answer that question.
So going on to the next question. So what's your strategy for testing and validating a hardware product when time plays a major role?
See, testing and validation, we can't skip. Like very little optimization, especially on time constraints. So what we suggest to do is, see, if you want to manufacture and ship out 1,000 units per day, so if you reverse calculate, like you can say how many units need to be tested in a minute. So you need to plan everything accordingly, right? So for example, there are a lot of test jigs possible. We have a lot of automated, semi-automatic, automatic test jigs that we can build. So a lot of times customers, they would have figured out, we help them execute. Sometimes we help them build those test jigs and execute. But it's, I think right now, that part of the problem, fairly good amount of automation is there, which can help us like do a full check more faster.
You almost know FMEA, right? Failure mode effect analysis. So I think that give you like an X-ray vision of what's going to fail. So if you want to test and if you know that okay, this is going to fail, you test for a backup, build multiple tests so that instead of waiting for one thing to happen and then realizing something too late, wanting to skip it, just build that failure mode effect analysis into the design itself. Optimize it to such a level. Building two pads for an alternate IC is because somebody thought, hey, what if that doesn't happen, or that IC didn't work, or that IC was not available. So building, getting that X-ray vision into the future, saying, hey, this can go wrong. So that far-fetched vision. There are of course methods like help you with that. There's proper standard charts, known methods. So using that is one of the methods. You don't have to worry.
You either test in the factory or you test in the customers.
You can't test in the factory as much as not at the customer's place.
You don't want to be
But not as a design. When you test in factory, not test in customer.
avoid customer returns. Yeah.
So moving on to the last question. After this, we can have full audience round. Okay? So last question for the night. What is one question that you would ask Murli, and Murli, what is one question that you would ask Praveen?
What is one question that
Would
Praveen wants to? Okay.
Do you have any question?
I think when you sleep.
No, actually, to be really honest, I've been told a lot that I need to focus more on sleeping. So trying to get as many hours as possible in the last couple of years at least. But yeah, had a big run of less than 4 hours sleeping for a long time as possible.
I know most of the people here.
Everybody is late. Yeah, I had to battle myself to sleep more. At one point, it was easier to not sleep. So I used to be less than 4 hours. Now I've tried to focus on getting it higher and higher and higher. So
I think that's important. Like as a hardware, all of us are hardware geeks here, right? So hardware geeks, we all like try to sleep less, like do more work. I think at some point, please balance it out, like because one thing that we have seen is hardware is also important, health is also important.
Hardware.
somebody really said silos.
What is hardware is also important.
Somebody really said silos. Right? Like, as long as I was doing my own work and I could manage with very less sleep, the moment it starts affecting team, right?
Yeah.
My decisions become unclear. I can't make fast enough movements. Then you're like for 2 hours of your sleep, you're wasting 5-6 hours of somebody else's as a team. Right? So then it starts hitting you. I think at that point you need to wake up and have absolutely good clarity on how you're affecting a team. So I think that's a main tip.
Life is a marathon, not a sprint.
Exactly.
No, this is very important for hardware. Hardware.
Irreversible decisions are too many and not enough.
We do have to split something.
Yeah.
But overall,
Yeah. Hardware, that's another thing. Like, be patient. Like, see, like I use every single opportunity to thank our customers, but also please be patient with us. Sometimes we make mistakes. Like, we are trying to improve ourselves. Like, we are not perfect. We have come so far, but we still have a long way to go. We have delays. We have quality issues have come down significantly. Like, I think we have close to Six Sigma now on the quality. But delays are something which is very unfortunate. We have sleepless nights, make sure we work very hard to make sure that there are no delays. But unfortunately, like there are a lot of ecosystem problems and our own like journey of getting better. So please be patient because it's a marathon.
Yes. So I think we spoke about like time, cost, and government constraint and stuff. How do you manage a skill constraint?
Skill, manpower, basic manpower, right?
Manpower is okay. Not having a particular skill and you want to do something.
Got it. Skill is like, see, always, okay, when it comes to skill, I have one example always. So it's like, I always take this example. If we had 10,000 crores today, can we build aircraft in the next 1 year? No. Even if we have 100,000 crores, it is not possible, right? Like, because there are a lot of skills that we don't have as a country, right? There are a lot of skills that we don't have even to build a plating that we use in our factory. Right? So, but I think it's a constant improvement, right? Like what we do is we invest a lot of time developing skills within our team, right? Like it's a continuous development. And one of the things is like we like when we hire people, we don't like really look for degrees. Like we have people from all different backgrounds doing some of the special jobs. Like we have some of the manufacturing CAM jobs done by people who have studied BCom or people who have done BCA, BSc in English or not BCA, BA in English and stuff, right? So we have all sort of background. So what we have realized is, so a lot of these skills can be developed, right? Like it's on-job training kind of thing. But they are the, when you invest in the skills and people, they don't leave. They are like, dude, like I have learned a lot of things here, like, they are, in a way, what we're seeing is they go a long way. They step up a lot of times. I think that's been our. It takes time. It's not an easy thing. If you want to hire someone tomorrow, it doesn't happen. A lot of times we have faced issues in skills, but over time we are getting better. Right? That's also some of the times like we have delays because we don't have enough some of the skills. Right? Like we need to get better. We are not there yet. Yeah, it's a hard problem.
Very interesting. I was listening to a podcast and it was a conversation between HR and a VP. HR says, if I upgrade the skill of this person and he leaves, what happens? VP says, imagine if he doesn't upgrade and he decides to stay. Right? What am I going to do then? So it's always better to upgrade for skills.
See, it's a two-way. You have to stay.
Also, you mentioned about the industrial mindset.
Yeah.
I think instead of chasing people's skills, we should chase people's mindsets.
Yeah.
That can absorb those skills.
Correct. 100%. 100%.
Like you said, all the degrees, they don't matter. The mindset is only the major.
Doesn't matter. Like, So,
Okay. Now over to the audience. Whatever question you have, you can ask them.
So I think what we can definitely do is people have traveled from far.
We'll grab some
Very careful,
snacks.
roam around.